Okay, this is a rather wonderful turntable that I've been repairing. It is, I don't know what it dates, uh, exactly how old it is, but it's pretty old, and it's got a built-in simple valve amplifier with a single tube. And I thought I'd just use it to sort of talk about how valve amplifiers work, because this is probably the most simple version of a basic valve amplifier. So the way that this thing works is you have the signal coming from the stylus, and that goes along this grey wire, goes to some phono connectors at the back, comes back in, goes into the back. Sorry, it's this one. Goes into the back of the tone stack. So basically the tone controls and the volume controls that are on the front. So the signal from the stylus is going in there. The sound is kind of filtered and adjusted for the tone using various capacitors and resistors and the potentiometers, which are basically sliding resistors. Then the signal goes into the circuit board. Okay, the signal that's coming into the circuit board is actually very weak, and really we need a strong wave to drive these. Look at these speakers; they're awesome. Look at these kind of like elliptical shape. But we need to drive a speaker, especially one like this, you need quite a big wave, so we need to amplify it. So that's where the valve comes in. And valves require very high DC voltages. So you've got your power transformer here, so that's taking the AC, 240 volts AC, and it's stepping it up to a much higher voltage. It goes through a series of diodes and this large dangerous capacitor, and that will rectify the current, so it converts it from an alternating current to a direct current, and then that feeds into the tube, or the valve. The Americans call it tube, we call it a valve, I think. Now the way a valve works is really clever. What it is, it's inside is a vacuum, and well, what I've done is I've drawn a diagram. So here's my terrible diagram of a basic valve. So you've got the valve itself. Inside you have a vacuum, and you have two plates at either end. At the bottom you have the cathode, which is kind of negative, relatively speaking. It's got a kind of a slightly negative charge, and well, relative. it's relative. It's not actually negative. And the anode, which is very strongly positive. So this particular one was running at 239 volts, and that's called the anode. All right. So underneath the cathode, you have a heater, usually a little 5 volt heater, and that heats up the cathode plate, and it basically kind of boils off the electrons from the metal. And the electrons are, as you might remember, electrons are negatively charged. They are then pulled across the vacuum to the anode because they're attracted to this very strong positive charge on this plate. So you have this flow of electrons going across the tube in this direction, going kind of up. Okay, so coming in, you have the signal, and this is the signal coming from the stylus that's just gone through the tone stack. Okay, so this is a very small like AC waveform. That's what kind of music and vocal sounds or whatever are. So you got your sound coming in, and that connects to a grid. It's like a mesh here, metal mesh. And what that does is it impedes or enhances the flow of electrons depending on where you are in the wave. So when the wave is in its positive portion, so for example, I don't think it actually goes up to 3 volts, but say it goes up to like 0.7 of a volt. Okay, but it becomes slightly more positive in this area of the wave, and at that point the electrons, because there's more positivity, the electrons are pulled through more strongly. Okay, so the electron flow is enhanced, and when it's in its negative phase, the electron flow is impeded. It sort of puts the brakes on this flow of electrons. So in that way, this waveform is translated via this what's called the grid, which is throttling or driving the electron flow, and you get a corresponding magnified wave, which is basically the same as the one going in, but bigger, coming out the top, and that gets carried onto either another valve stage, or it will go to this thing, which is called the output transformer. So in this circuit you've got like the power transformer that provides the power, and you have an output transformer. So the output transformer is taking these red and blue wires, are getting the signal from the valve, this amplified signal, but it's actually a very, very high DC signal, and it's so you wouldn't want to fire it straight into the speakers, but A, because it'd be very dangerous, but also because you need low voltage, high current to drive a speaker. So that's what this transformer does. It's a transformer is basically two separate circuits. So this circuit here is isolated from the output circuit, the one that actually drives the speakers. So this one is actually safe, and that one's the one that's pushing the speakers in and out, and this one is the one that's connected to the valve. So that ensures that it's completely safe, and you can actually sort of touch these terminals here, and you'll be okay. Don't do it anyway, just in case there's a problem. But that's basically how it works. So those are the components that you need for a very, very simple valve amplifier. More complex valve amplifiers will have more valves, and they will have more transformers as well. You have, for example, my guitar amp, you've got like a power transformer, an output transformer, and then you've also got a transformer for the reverb, and you have another one for the power supply as well. So they can end up being quite heavy and quite expensive as well. But this is a very exciting and beautiful example of a simple valve transformer, and you've got all these lovely old resistors and capacitors. Look at them, they're really great. Look at that orange one there, brilliant. And there's the valve. I'll just quickly show you what the valve actually looks like. So they're a bit like light bulbs, these things, except for they don't screw in like light bulbs. They pull out, and they got the pins. So there'll be some pins for the supplying the cathode, some supplying the anode, some will be supplying the heater, and this one's actually got a couple of stages, so it actually amplifies it twice. But there you go, and this is a Russian one, and it must be very old, and I'm amazed it's actually still working, and working really well, because it must be at least 40-50 years old. Anyway, that's the little boring lecture over with. I hope you found it interesting and educational.